Bismillahirrahmanirrahim. Welcome to my channel Learn Math with Syed Ali. Today we will be learning prime numbers and prime factorization. So before we start prime factorization, we should have a definition of prime numbers. Prime numbers are natural numbers greater than 1. So that means 1 is not a prime number. Please note it down that 1 is not a prime number. There are only natural numbers greater than 1 that cannot be formed by multiplying two smaller natural numbers. That means that cannot be formed. For example, before example, we can read another definition. Prime numbers are those numbers which have exactly two distinct divisors, that is 1 and by itself. So they can only be divided by 1 or by itself. So as we said that 1 is not a prime number because it does not have two distinct divisors, right? Because it has 1 and by itself. So 1 is 1. So there is no two divisors, right? So two numbers. And that cannot be formed by multiplying two smaller numbers. So we will see. That means first prime number is 2, then 3, then 5, then 7. 9 is not a prime number because it can be formed by two other natural numbers. That is 3 times 3 is 9, right? So that can be formed by multiplying two smaller numbers. So, and 9 is not a prime number, that means, right? So it has got more than two distinct divisors, right? So it has got 3 as another divisor, right? So it's come in the another table, you can say. So 9 is not a prime number. 10 is not a prime number because 10 can be formed by two other smaller numbers, 5 to the 10, right? So 11 is a prime number. It cannot be formed by multiplying any two natural numbers. So it doesn't come in any other table, right? And it can be only divided by 1 and by itself. So 13 is a prime number. 14 is not. 15 is not. So you can learn now both definitions. So what is natural number? Before going into natural numbers are all those numbers which starts from 1, 2, 3, 4, 5, 6. So these are all natural numbers and going up to infinity. They're called natural numbers, right? So I write it here for you, natural number. Natural number. So, and in natural numbers, we have done two things, like the even numbers and the odd numbers. So even numbers are those numbers which are divisible by 2. Even numbers divisible by 2, right? So this we have done before, divisible by 2. And odd number, not divisible by 2. Not divisible by 2. So this is all natural numbers, means it starts from 1 and it go on to the infinity. So prime numbers are also the natural numbers but greater than 1. So 1 is not a prime number, right? So it starts 13, 15 is not a prime number, 16 is not a prime number, 17 is prime number, 19 is prime number, 20 is not a prime number, 21. Now 21 is come up like 3 times 7 is 21. So that means there are tables which are going through in 21. So that means it has more than two divisors, right? One is always a divisor, right? So 1 times 21 is 21. So 1 is always a divisor, right? And by itself is always a divisor, right? So 21 is not a prime number. 22 is not a prime number. 23 is a prime number. So you can check by yourself the rest of the numbers which are prime. So I gave you 2, 3, 5, 7, 11, 13, 17, 19, and I have the definition, and we can read it in both way and can check the number by both definitions. It is good. So natural numbers, it starts from 1, right? So what is like integers? Integers are those numbers which are having a negative counterpart of the number as well. So 1, 2, 3. So if we have 1, 2, 3, 1, 2, 3, right? So these are all natural numbers. So now we will see that how to factor the numbers or prime factorization. So in prime factorization, what we have to look at it is some table which is passing through 63. For example, we want to prime factor 63. So how to start it? It starts from times table. So if I say, okay, 7 9s are 63. So 7 times 9 is actually times. So 7 times 9 is 63. Right? And now 9 is furthermore can be divided as 3 times 3. Right? And now further there is nothing, right? So because 3 is a prime number, so C is a prime factor. So how many factors we have for 63? Number 7, number 3, and number 3. So 7 times 3 times 3 is equals to 63. So this is how we calculate prime factorization. So what are the prime factors of 63? That is 7 times 3 times 3. And these are all prime numbers. You can see from my list that 2, 3, 5, 7, 11 are the prime numbers. Right? So let's take another example. 72. Let's break down 72. Right? So 72, you can call the table, or you can start with 2 because 2 is the first prime number. So if it is 2, then its passing is 36, right? And then again it's passing with 2 and it's passing with 18, right? 18 times 2 is 36. And again 18 is 2 9s are 18. And again 9 is 3 times 3 is 9. So all possible factors I have now which are prime, and I can say that 2 times 2 times 2 times 3 times 3 is 72. These are my prime factors, right? So I can circle them and then I can multiply them. So I write it here. Now we test it for multiplication. 2 to the 4, 4 to the 8, 8 and 3 3 is a 9. 8 times 9 is 72. So we are good with our factors. So these are all possible factor of 72. Now we see another example, maybe 96. Right? So 96, if you divide it, start with 2, you can start with 2. So 2 4 is 8, 2 8 is 16. 2 times 48 is 96. Then 48 can be divided as 2 and 24. Then 24 can be divided as 2 and 12. Then 12 can be divided as 2 and 6. And then 6 can be divided as 2 and 3. So all possible factors are like these, right? So 2, 2, 2, 2, and 3. So we can also write it as like 1, 2, 3, 4, 5. So I can write it 2 to the power 5. 2 to the power 5 times 3 is equals to 96, because we already done exponent. This one also can be written in terms of like 2 to the power 3 times 3 to the power 2. This one can also be written as 7 times 3 to the power 2. 3 to the power 2 is 9. So other factors can be 9 times 7 is 63, which is the first factor. But we have to break it until every digit is prime. So we have these examples. You can solve, or you can have more examples on it. So let me have few more examples for prime factorization. So you need to start with the table of 2. That is more good. But if 2 is not passing, you can select any prime number from the list which is passing into it. So for example, now if I have 49. So 49, I have to prime factor it. So when I factor it, I will say 7 times 7 is 49. So 7 times 7, 7 square is my prime factor for 49. If I have 56, so I have 56, it's passing into 7 times 8 is 56, but 8 is again breakable as 2 times 4, and 4 is again breakable as 2 times 2. So what are my prime factors? 7, 2, 2, and 2. So I will write 7 times 2 times 2 times 2, and I will check. 2 times 2 is 4, 4 times 2 is 8, 8 times 7 is 56. Or I can write it 7 multiplied by 2 to the power 3. Both are correct way of writing 56 as a prime factor. So what are the prime factors of 56? 7 times 2 to the power 3. So you can have many more examples. Maybe 100 factorize 100. So you can factor 100 with that. 2 times 50 is 100, then 2 times 25 is 50, and then 5 times 5 is 25. So what you have prime factors like 2 times 2 times 5 times 5, which is equals to 100, or you can rewrite it as 2 to the power 2 times 5 to the power 2. This is also 100. So in any case, it comes out as 100 if you multiply. So you learn in this exercise what the prime numbers are, how you can define them. Is 1 is a prime number? No, 1 is not a prime number. So natural number starts from 1. Whole number starts from 0. If I say what are the whole numbers, so I will write 0, 0, 1, 2, 3, 4, 5, etc., etc., etc. And I said integers also belongs to negative counterpart of each positive number. So that means -1, -2, -3. We will have another lecture or another lesson on numbers and types of the numbers, how we can define them. So today we cover only the prime numbers and how we can factor or prime factorization. Hope you like the video. If you like it, subscribe my channel, press the bell icon button. Thank you for watching.